My man. Oh. All right. We are jumping into a new scenario. We're jumping into a new scenario. It's very much like the last scenario we did. The last scenario, we graphed the height of a car on a 150-foot tall Ferris wheel, yes? Now, it says, suppose the Ferris wheel has a diameter of 150 feet. Same thing, right? From your viewpoint, the Ferris wheel is rotating counterclockwise.
East way.
Right? Your friends board the Ferris wheel and the ride continues boarding passengers. Their car is in the 3 o'clock position when the ride begins.
They have a Ferris wheel for cars?
Yes. They call the cab in a Ferris wheel a car. Their car is in the 3 o'clock position when the ride begins. Sketch the height of the car for 2 turns. So it's going to start here. It's going to go counterclockwise. So is it going to start going up or down? Up.
Like an elevator.
Okay. Now, remember, how did we do this yesterday? We did this. 100. So each square was 10 feet. And we did 1, 2, 3, 4, 5, 6, 7, 8 squares per turn. So we're going to do that again. We're going 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we go 1, 2, 3, 4, 5. That's 50 feet. 1, 2, 3, 4, 5. That's 100 feet. And 1, 2, 3, 4, 5. That's 150 feet. And where does it start at the beginning? The 3 o'clock position, right?
Yes.
How high is the 3 o'clock position?
Right here, 100 feet.
Why 75, Ryan?
Because the highest point is, if it's 3 o'clock here, the highest point is 150.
Yeah, so height-wise, 3 o'clock is exactly between 12 o'clock and 6 o'clock, right? In the middle. In the middle of 150 and 0. So the middle position, and remember we used this green line yesterday, at least in my class we did, is at that 75 mark.
Are you recording this?
Yes, I am. Yes, I am. So the line went right about there at 75, right? And that's where we started. That's where we start our little thing. And at 3 o'clock, if it's moving counterclockwise, it's going up, right? Now, we said it takes 8 squares. I don't know how long a square is, right? But we chose 8 squares. But how long is it going to take to complete one full turn? 8 squares, right? So I'm going to put a dot at that 75 point because one full turn puts me back at 3 o'clock, right? Yeah. And then another full turn puts me back at 3 o'clock. And that's another 8 turns. You're excused. Now, if it took 8 squares to get all the way around, how many squares did it take to get halfway there? 4 squares. And where is halfway there? How high am I? 75 again, right? But this time I'm not going up. I'm going down. I'm at 9 o'clock at 4 squares. So I'm at 75 there as well, right? And then I'm at 75, 4 squares at this again, after this again, right? 1, 2, 3, 4, right here. Okay. I got some dots in here. Now, how many squares does it take me to get to the top? If it takes me 4 squares to get here, how many squares does it take me to get there? 2 squares, right? So 2 squares here, but where am I? How high?
150.
150? Why 150?
Because you're at the top, you're at 12 o'clock.
12 o'clock, and the wheel has a diameter of 150, right? So at 2 squares, I'm all the way up here. Where am I, Trey? Where am I 4 squares after this? After the top. Bottom. 0. So 1, 2, 3, 4. I'm down here, right? I got 1, 2, 3, 4, 5 square or 5 dots graphed. Can I do a curve that connects all those? I think so. Let's do that. Forgive my lack of artistic merit.
On someone with artistic merit, I could do it. I do disagree with my artistic merit.
What do you think? Eh?
That's pretty spot on.
Pretty spot on. Thank you. So, back to this. At the top. I'm at the top. How many squares does it take me to get back to the top? Takes 8 again, right? So let's make another dot there. 1, 2, 3, 4, 5, 6, 7, 8. Right there. Okay? And I'm at the bottom. Stephen, how many squares does it take me to get back to the bottom? 8 squares. So 1, 2, 3, 4, 5, 6, 7, 8. Is that right? Yeah, I counted right. So now I got 1, 2, 3, 4, 5 more dots. Now I'm going to connect those dots with the curve. Does that sound good, Julia? So let's do that. Right here. I don't like that. What's that? That's right. I gotta redo this one. There we go. Is that better? That's better. Okay. So, we create a sketch of the height of your friend's car for 2 turns. So, I start in the middle. I go up to the top. Up to the top. Back to the middle. Down to the bottom. Back to the middle. Up to the top. Middle. Bottom. Middle. 2 full turns, right? 2 full turns. Now, it says, explain how the features of this graph relate to the situation. You get to write a paragraph, huh? How fun is that? Let's talk about this, though. Let's copy. I'm going to copy this whole graph that we just made. I'm not going to ask you to do it. No, come on. Let's do it this way then. Ah. No.
I can't.
Let's group.
Grandma's mom's side.
Man, it doesn't let me group. Oh my gosh. All right. So, we're just going to have to do it from this page. Good morning, Ethan. Do you have a conflict? At the end of class, I marked you absent, so at the end of class, let me know, and then we'll put you on my schedule so that I don't mark you absent again, okay? So, at the beginning, right, I'm in the 3 o'clock position. and I'm going clockwise. So I'm going up, right? Which way is my height going? It's increasing, right? Which makes sense with relation to my story, right? Now, do I go up and then go down? So I go straight up to a point and then I go straight down, right? Not exactly, right? I'm going in a circle, which means I'm not going up at the same rate. I'm going up really fast here, right? Am I going up or down really fast here?
No.
No, I'm going more that way, right? Matter of fact, at the top, I'm going all that way. Right? But as soon as I leave that top spot, I start going down, right? I start going down. Over here, I'm not going left or right at all, right? It's all down. But as soon as I leave that spot, I start moving, well, to your right, right? Here, not going up at all. Here, I'm all going to the right. And then I start going up. Okay? How would... Now, this one I do want us to answer. Number 3. How would this sketch change if the diameter of the wheel changed? How would this sketch change if the diameter of the wheel changed? Please, Frank. Please. Thank you. Thank you. If the height of the Ferris wheel changed, how would this graph change?
The bends would be smaller.
Or bigger, depending on.
Yes, yes.
Well, let's say this. Let me ask this. If the diameter of the Ferris wheel was 200 feet, where would these peaks be?
Higher.
How high?
50 more feet.
Up to 200, right? Where would these valleys be?
They'd still be
Still
the
the
same.
same. They're
Bam. Okay. How about this
to
line?
100.
To 100, right?
Yeesh.
So this goes up 25. These go up 50. Otherwise, it's going to look exactly the same, right? What if this goes down? What if the Ferris wheel has only got a diameter of 100 feet?
Okay.
Where at the top? Somebody other than Brandon and Andrew. Taylor, where at the top if my diameter is 100 feet? It goes down to what? To 100. Good. Good. How about the bottom? Jeff, where's my bottom go if my diameter changes to 100 feet? It stays the same, right? Because the bottom's the bottom. Where does my line, my middle line go, Ethan? Where's my middle line go if my diameter goes down to 100 feet?
The line would go down to 50.
Go to 50. There you go. Good. So we're getting the idea of some of the features of this graph. Okay? If you translated the sketch of your graph down by the radius of the wheel, what the heck does that mean? What would the x-axis represent in this situation? You translated, oh, I know what it's saying. Okay, check this out. You guys don't understand what they mean, but I'm about to show you. They're saying if you translate this curve down by the radius, what's the radius of this Ferris wheel? 75, right? And I want to translate this sketch down by 75. It's saying, Brandon, I want to translate this down by the radius of the Ferris wheel. So I'm going to take this and I'm going to move it down 75. So where that dot was before, at 75, is
Underground
a,
Ferris wheel.
it's an underground Ferris wheel, I'll give you that. But
If you go down, there's a bunch of demons and angels and stuff down there.
have we seen something that looks like this before? I wish I could group all these.
Now it's off.
It is. There we go. It's good enough. Good enough for government work. Did you hear my voice crack just then?
Now that's
Wow.
gonna be on the recording. Every single
That's
time
embarrassing.
wants more knowledge about this subject.
Good.
All right. So, yeah, be nice. Be nice. Yes. See, this is like forced niceness, right? So, what does this look like now? Have we seen this before?
Yes.
Well, if you translated your sketch down, so it's asking, if you translated your sketch down 75 feet, what does the x-axis represent in this situation? Does the x-axis represent anything different now than it did before? No, it's the same thing, right? What about the y-axis? What does the y-axis represent? Does this represent height anymore? What does it represent? So here, I'm at 0. I'm at 0. 0 feet in relation to what?
0 feet in relation to the top of the, no,
Close. I'm 0 feet above or below what?
the ground.
The center of the Ferris wheel, right? The center of the Ferris wheel. So I'm 0 feet above or below the center of the Ferris wheel. Here, I'm 75 feet above the center of the Ferris wheel. Here, I'm at 0 feet above or below the center of the Ferris wheel. Here, at negative 75, I am 75 feet below the center of the Ferris wheel. Do we see how moving this thing down changes our perspective of the Ferris wheel? Okay. How can we create a more precise sketch? How can we create a more precise sketch? I'm going to skip that one. How much time do we got? I don't think we got much time.
We got 9 minutes.
All right. Here's what we're going to do. Tomorrow, we're going to jump into paper plates. I think. I got to talk to Mr. Erickson, but I think we're going to do paper plates tomorrow.
So
All right? Say again?
So we're done.
We are done for today.
What are we doing? What are we doing?